Good morning, everyone, and welcome to our Levc Tech Day. It is genuinely so good to see so many of you here, so thank you for making the effort to come and see this momentous event. This is the start of a new technology for Levc, and we're very excited to be able to share that with you. Today is about showing you that technology and walking you through what it can do. Innovation that will allow Levc to transition into its new strategy of delivering more accessible mobility solutions to people than ever before. This technology will allow us to expand our product portfolio and offer adaptable spaces with multiple configurations to meet all of the market demands that we see available to us. Today, we'll show you that technology. But before we do, I'd like to take a brief moment to talk to you and reflect on the history of Levc that has got us to this point today. Levc has more than a century of mobility within its DNA. Levc has been delivering spacious mobility solutions for longer than mobility was a buzzword. In 1908, Levc delivered its first taxi with innovative turning circles that enabled it to meet the challenges of navigating the Savoy Hotel roundabout. Levc still has a world-leading turning circle, which remains crucial to this day to enable the public to access and maneuver in some of the most challenging urban environments around us. In the last decade, under Geely ownership and investment, our journey as a mobility provider has rapidly accelerated. Our visionary owners have delivered this incredible facility that you see today, and hopefully you'll be able to walk around and go and experience what it is that we deliver and how we deliver it. This was opened in 2017. And it was UK's first automotive factory dedicated to electric vehicle production. That investment has also delivered the world's most advanced electric taxi, the TX, with its innovative range extender technology. That technology has supported the adoption of electric vehicles and cleaner air in our cities. Since 2018, this factory has manufactured more than 10,000 vehicles, which has supported the export of the electric black cab across the global markets, including the EU, Middle East, and Asia-Pacific regions. These vehicles have traveled more than 500 million miles, preventing more than 160,000 tons of carbon emissions into the atmosphere. Our vehicles continue to meet the growing demands of society's needs for spacious electric vehicles. But now to the future. As the automotive world transitions into fully electric technology, there is a rapid demand for new zero-carbon vehicles that are at home both in and outside of the cities. Levc has a vast heritage in delivering purpose-built solutions. And it has the legacy of designing, engineering, and manufacturing vehicles that meet these needs for accessible mobility with uncompromised space. Here's what our customers have to say about our vehicles.
In 40 years of driving, this TX is the best vehicle that I've ever driven.
So I have braille controls in the rear so the passengers can control the ventilation, and I also have a hearing aid loop so I can communicate with my passengers. And my wheelchair ramp is a really useful feature. I'm actually picking up a lot of new mothers at the moment because it's so easy for them to put their pushchairs in the back of the cab. I love that my TXC is accessible for everyone.
With my TX, the running costs are more manageable than they ever were with a diesel taxi, thanks to the electric charging capabilities and the range extender.
Even though it's a new electric vehicle, it's still the iconic London taxi. There's loads of space, loads of room to stretch out, and the panoramic roof is brilliant. You can actually see London when you're inside them.
Here at Brewery Road, myself and the team value our customers and are very passionate about the service that we give.
Our vehicles are loved by customers around the world. They offer a versatile space that is accessible, safe, and electric. But we can't stop there. Society's needs for mobility solutions and the way that they use the space within them is ever-changing. Who better to meet that need than Levc? It is our heritage our passion for innovation, our support from Geely, and our unique blend of capabilities that will allow us to deliver the needs of society and meet our mission of providing safe, green, smart, and accessible vehicles to more people than ever before. After all, continual innovation in the mobility sector has been in our DNA for more than a century. It's now time for us to expand our offering. There is one very crucial word within all of this: space. Our future products will be about giving space back to customers, about optimizing the space within the vehicles. It will be about offering customers a versatile, adaptable space with multiple configurations so they can shape the space they need for their requirements with infinite possibilities. This is X-Space. It is with great privilege that I get to stand here today and introduce you to this new technology as Levc transitions into its future direction, as we today launch our space-orientated, fully configurable architecture for an ever-changing world. And on that note, I would like to welcome onto stage Alex, our CEO, Kent, our Chief Architectural Designer, and the King's representative, Deputy Lord Lieutenant Les Ratcliffe, to support with the activation of this new technology here today. We will start this activation with a very simple countdown. 3, 2, 1. Off. I'll now hand you over to Kent, our Chief Architectural Designer, that will talk you through the technology behind this.
Yes, hello everyone. It's a really pleasure to meet you today here. I have been leading, among other things, this architecture. So I'm going to talk about SOA today. SOA, that is a space-oriented architecture. And what I mean by that, I'm going to tell you soon. It depends on 5 pillars, brand pillars, I used to call them. It's the space of the vehicle, it's the safety, it's the performance of it, and it's green and smart. But furthermore, SOA is a part of the umbrella of SEA. SEA consists today of 5 architectures, coming from small cars we call SEA3 up to the largest one, that is SOA. In principle, there's 5 architectures for the moment, over 40 vehicles is developed on that. And so the unique thing about SOA here is the architecture, the platform, the chassis is unique for SOA. But many of the other, I would say the seat system as well is unique. But many other components is then shared with SEA, for instance, batteries, motors, and so on. That means big volumes, good quality, and good prices. But also that I can follow what happens in SEA. So every new technology we will introduce is applicable for SOA. Okay, if we then start with these brand pillars here, we talk about space first. We call it space-oriented. One thing with space is that you have a broad bandwidth when it comes to sizes of vehicles. So, for instance, I don't be boring you with too many measurements here, but I can say, for instance, axle distance can vary from 3 meters up to 3.8 meters. And we have tried to make the interior as flat as possible, and that means that is all flat, I would say. That means that we can put in really long rails. So the second and third row is on one rail. That means that we have a very high flexibility how to use the seats. And the fourth row can be folded down when not used, so you get a complete flat floor. We have also think about to use this for different type of vehicles, because an architecture means that you can build different type of vehicle. Otherwise, it's not an architecture, it's a vehicle. So we can build, if we talk about driver position, we can go from the lowest position, that is 320, that you can say is a low SUV. Then we have a mid position, 345. That is, okay, I should swap that so it's easier to see. It can be then, it's 345. It's like a pickup or a very high SUV. Then on the highest position, which is very good for commercial use or for a high MPV. But to get this space in the vehicle, you have to do a very smart layout. And what I mean with layout is that you package everything, you integrate everything in a smart way. I'll give you just 2 examples here. Normally you find a battery, low voltage batteries in the front, and normally on an electric car you find an onboard charger in the front as well. We're taking them out. So the battery we position on the driver's seat, so it's easily accessible there. We have put the onboard charger on top of the battery below the floor. So we free up space in the engine bay. That means that we can have really short overhangs and give more space for the passengers and so on. And then short overhang, but still safe car, I would say. The only big component we have left in the engine bay is the engine, and we need it there. That has given us, we do some kind of, when we check efficiency, we look at how long is the car and how much flat floor usable space do you have. And in this kind of flexible vehicle, it's not only the length of the floor, it's that it's completely flat. So we're using 75% of the interiors is a complete flat floor, and giving us a lot of flexibility then. An average, if I look at other MPVs and whatever cars, is like 67. And there's a huge difference. We also worked a lot with, to get it, because this is a high vehicle, we also work with the packaging to get it as low as possible, even if you have the battery underneath. Normally you only have a structural beams, but we have a big battery as well. So for instance, we have the step over height. And so if for instance, we talk about the front, the first step there, you have 2 steps. We are 74 mils lower than our competitors. But the height is equal when you come into the car. I forgot to say it again. I always forget this, With air spring, we can lower it 20 mils more, because we have air springs possibilities in the rear. Then we have for the passenger area, we have the first step in is slightly higher than the competitors, but you don't notice 5 mils really. But the second step in, the height of the floor, is 64 mils lower. And here, the air sensor can lower it additionally 40 mils. Then, this is also good to taking with you heavy things. It's a good loading capacity in this car and this architecture. And then you have to have a low lifting height. Here we are 28 mil lower than our competitors. But here with air spring again, you can lower it additionally 94 mils. So that was the space-oriented. Do you think it's space-oriented? I hope so. Then we come to safety. There we want to be among the leaders, not overall compared with every vehicle, but compared with this class of vehicle, we want to be leading. That means that we have to meet 5-star, and we do. Our score, overall score, is 85%. To get 5-star, you need to be 76. And just as an example, I talk for protection of the driver as the passenger in the vehicle, we are at 91, and you need to reach 80. So it's very high safety degree. I said, even a normal car that is easy to make safe, I can say, it's is in a good range. This, so it's in a good range compared even with others. So we are green, and I nearly forgot to say it. This is the number from our prototype. Because when I develop things, I want to meet all the requirements before I even do a prototype. So we do prototype with soft tools. So I know by simulation that I meet all the requirements, otherwise I don't do the prototype. So this is prototype testing. We will do this soon, the next, with the coming from hard tool, we call it, the final tools. Then, I always, when I do something, I have a safety strategy, how to manage load, how to manage different collision systems. So in the front here, for instance, we have crash boxes that is good for low speed and medium speed. And then we have the rest of the structure that we fold in a special way. You will see that in the movie here. And then it's the key point is well to have a stable compartment. So you have to transmit these forces into the rocker that we have made in aluminium, this extruded aluminium. And then it goes also underneath the car and also connected then to the battery. So we use even the battery case as a part of our safety system. Many see batteries as unsafe. I use it as a part of the safety system. Here are some pictures and film. We're taking out the engine and so on. So normally when we do the crash, there's more things in it. But just to see, you can see how the structure working. And here you see the final result from our first testing. This is 56 kilometers per hour full front. And as you see here, that is nothing left of the front. In principle, it's totally squeezed together. Why can't we do that? You know, the normal vehicle can't do that. First of all, I've taken out this component that we can't crush. And we will not crash because you need a 12-volt battery to unlock the car and so on when you have a crash, so you don't want to destroy it. It's only in the end you can disconnect it if you have a cable broken or something. So, and the onboard charger is a very heavy, massive aluminium part, so that is out. And then the engine, by releasing the subframe in the crash, when the subframe is hit, the lower frame of the car, when it's hit, the bolt releases, and the engine goes below the car. So it doesn't even hit the dash, and it doesn't hit the battery. And then you can squeeze the whole front, and you have short overhang. One thing that is very difficult, you should know, is when you have a heavy car. These have a crash weight of 3,100 kilograms. Then you have this compatibility testing now, because I have seen that the old Euro NCAP requirement or China NCAP requirement demand very stiff cars, Then we're building SUVs that weighs 3 tons. And then we have mini cars, They are dangerous in the traffic. So they invented this compatibility test. So you have a bullet vehicle that is a light, smaller car, and the front consists of this deformable front, deformable barrier, you can call it more or less. And then you hit this with your vehicle. And here we manage green with a car with 3,100 kilograms. And you can look at the barrier afterwards. What can happen if you have 2 strong front ends is that you penetrate this, and then you don't meet the requirement. And then they also measure how deep you have done, how uneven is the surface. If it's too uneven, you get deducted. But we meet the requirement in this, on this 3.1-ton vehicle. And then we have the side pull. This is a legal requirement. You have one hitting point, as you see. This is the legal hitting, you see. And many car makers, they only do the pull in this point. Then they're green. We do it along the whole side because it's an electrical vehicle as well, You have to protect the battery in this side collision. So we do it in 15 points. So we have the same safety wherever the pole hits. And the battery here again acts as a support for the rocker. So the rocker is taking, and the structure of the vehicle is taking the energy, and the battery box is supporting it only. And have very minor deformation. No cells is broken or damaged or even hit by anything. That was that pillar. Now we come to the next pillar. That is performance. Then performance, I think of chassis, and I start with chassis. To get good performance, you have to have a rather advanced chassis. I don't say that McPherson is really advanced. This is a rather normal chassis. But what we have done here is to have, instead of having a single lower control arm, we have split it. That means you get the vertical hard points for the chassis movements. And that improves something called scrubbing angle. I don't know what that is really, but it improved that. The chassis people said to me. So that is good. And then we have put the steering gear in front of the engine. That's also good for steering. And then we have CDC damper, continuous damping control. That means that you can change the damper characters while you're driving. It can be sport, you can be soft, and so on. So you can change the character. And then you have in the rear, we have our own. I said the chassis and the underbody is developed in-house. We don't use any system supplier, so it's our own IP. And the rear, we have done a new type of multi-link in the rear. And on that multi-link, it's that to have good performance. And if I should put an engine in here, you know, I can't have a stiff rear axle. I need a multi-link system. Here I use also some CCD damper. And what is really key, especially when you have a multi-link rear axle, that to have a good spring ratio. Some cars have very low spring ratio. That means, for instance, if you have an arm here, this is the wheel. They have the spring in between, more or less. We have put the spring 0.7 nearly, is 70% close to the wheel. So our spring is very close to the wheel. And that means that you have higher load capacity by 25%. And that is very good for this type of cars, that we have this good spring ratio. And especially when we're using air spring have a tendency to be really big if you have to take high loads in them. But we're keeping down the load about 25% better than competitors. Let's see. All of that here have improved ride and handling, 10% roughly we say. We have very good grip. And we have strong rolling resistance. I should give you just some example of that here. For instance, pitching. When you know, here you have a very strong vehicle. You know, you can have 200 kilowatt in the rear, 200 in the front, total system effect of 540 horsepower. This car, I don't know exactly figures, but it should be able to do 0 to 100 in 4.5, 4.7. It's a sports car, more or less. That means that, you know, an e-motor, all the torque comes as one, so it's easy to get it to pitch. Our pitch is a little bit over 2 degrees. Our competitor is over 3 degrees. We're taking down the pitch to 30% compared with competitors. When we're braking, we can say we're equal. Then when you do curve, you want the car to resist as high gear load as possible. Otherwise, you then start slipping. We have 0.73 in G. And a best competitor, European, we found is 0.7. American MPV, 62. That is a big difference. And then when it comes to how much the car is rolling, our car rolls 4.9 degrees. The American MPV, 6, and 5.5 for the other. So it's small, less in rolling, better in grip. Excuse me. Now, to get good VD performance, vehicle dynamic performance, to get a low noise level in the car, you have to have high stiffness in the car, not only statical, but also dynamical, and we have. Here I show some figures comparing. You should know that the Japanese luxury MPV, that cost over 1 million RMB in China. And it have a torsion stiffness of 12,000 Newton meter per degree. That was a long time I saw that bad figures, I would say. The German brand premium MPV here have 20,000. Now it's start to be something, you know, when you're coming over 20,000. And the best, I think, a premium SUV German we have measured is 33,000, and that's a very good number. I said they should be proud of that. But we have 41. That is what you have in racing cars, in principle. And that is good for NVH and for road holding on this type of car. And as I said, it's good for NVH. So if I look at road noise, here we drive on 60, on bad roads, you know, 60 kilometers per hour. The luxury German here, 73 dB, bad value, I would say, today. Then we have the Japanese, that was costing over 1 million RMB, 72. And then we have this premium car. I mean, that was the best car on the market when it was launched. I will not tell you what it is. That have 70. And we get, in our prototype, 69. Then, you know, the interior is not quite right. So the high-frequency noise will be taken down even more when you have the right acoustic material in the car. But in the prototype, we have 69. That is proven that the structure, everything's working. And only to reduce 1 dB, because this overall 1 dB, you know, only to get that down 1 dB takes a lot of effort. To get down from 73 to 69. Then they have to change the whole architecture to do that. It's not a small change to come down with that. Then we talk about green. And when I'm thinking green, I'm thinking, you know, to have efficient solution. And so I look at, for instance, energy consumption, especially when we have this big vehicle. Energy consumption depends on the EDS, the CD times I. We have a big car, high car, so it's a little bit difficult to get the lower CD. We have the weight of the car, we have the rolling resistance, and we have the thermal systems efficiency. I can say the rolling resistance I use in this calculation is the same tires as I use in the VD testing, so it's no cheating. So I have economic tires, I have sport tires, no, same tire. And the figures we see here, 19.3 in the Chinese cycle, and in the VLT is 21.5. And that's rather good figures for that kind of cars, you know. Really good cars with CD 0.2 and so on. They can come down to 16 perhaps, something like that, you know. When it comes to energy consumption, this calculation is done with silicon inverters, efficiency of 88%. We're moving towards getting in the silicon carbide chips that takes it down up the efficiency to 92. And then one really important thing, if you read a magazine and you see the rear-wheel driven car consume this, and then when we have all-wheel drive, it consumes 10% more. It's not here, because we have a disconnect in the front. And you have 200 kilowatt in the rear, so you never use the front engine. It's only with full throttle acceleration you're going to use it in principle, or in condition that you need to use all-wheel drive. Otherwise, you don't use it, so you're taking no losses. A little bit about the thermal system. We have a standard heat pump, and many cars today, to get them cheap, they put in PTC element only instead, no heat pump. We have it. And only that gives this saving, 12% at -10, 16.5 at +10. Then we have also intelligent steering of this, how we control the water, how this goes, and so I'm not an expert in this. You know, we have 26 different modes that we're controlling, different driving conditions, you know. We have EDS heat recovery. You have losses in the engine. We take care of the heat if you need it. And then we have 3-zone climate system in the front with additional climate unit in the rear. And all the hardware is already installed in the car. But what we're working with now is to control this. So for instance, if you only are the driver, you only cool down that area and heat it up. The rest, you don't send any cool air to. So you feel where the person's sitting, and by that you're controlling, also get down the losses. The loss curve over there, the yellow one is the energy consumption when you have no heat pump, and the lower curve is with heat pump. I'm over time here, but should I continue? If I then look at the battery side here, we have the smallest battery, 73 kilowatt hours, LFP. That is a good price battery. Then we have the middle one, 102, and the big one is 120. And here is a little bit the range figures down there. I don't want to read all these blurry figures, but according to VLTP, you know, for Europe here, 578 kilometers with a 120 kilowatt battery. And it's for this type of car, again, I say good range, size range, you know, to have. And it's also the new technology here. We call it cell to box. You can cell to pack was the name. Cell to pack that means that we glue the cells directly in the box. The first generation was cell to modules, and you put the modules in the box. And we have also in this battery box squeezed in all the control electronics, so there's no control box outside the box. So energy consumption is very important, size of battery so you can get the right distance, and then it's charging time. This is a 400-volt system. We have 30 minutes to go from 10 to 80%, and you can't do it better, I would say. We're using the maximum capacity we can charge these cells with. We have made even thicker cables to charge it, to carry this high currency. And if you don't need fully charge this battery, you have only 100 or 200 kilometers back home, you stay 10 minutes at the charging station, you got 200 kilometers extra. Now, my final word a bit about architecture and platform. Then I stop, I promise. We have one architecture with two platforms. I call it a premium platform and a commercial platform. And the big difference with them is that on the premium platform, I have a specific rear floor that can carry multi-link chassis, and this fourth row, you saw here the flipping down, you will see this later here as well. And on the commercial one, I just have a flat floor and a very simple rear end and leaf spring. And that's very good for a commercial vehicle. You can take a lot of load in them, and it's cheaper, of course. And that means that it is very versatile. See, it's coming up. It's a very versatile platform. So normally, you have to say this architecture should be premium, or it should be volume, or it should be base, It covers the whole spectrum. That's very, very versatile. Now we see it. Now comes that was my final. So that I am here. It was a pleasure of me to talk about this. I end with a movie presenting a little bit SOA. It's just
Have you ever wondered what future mobility will look like? We've been dreaming and creating. We release the limited space for unlimited imagination. A large, flat floor, a wide range of wheelbases, designed for many use cases, including premium and multi-purpose passenger cars and commercial vehicles. The flat rear suspension and underfloor design support space switching between passenger and luggage compartments. Ultimate cabin design brings maximum space back to the user. We remove any constraints of space to enable everything to be connected. Face recognition, voice control, smart onboard AI interaction that's designed to support all aspects of mobility, high-level intelligent assistant driver technology, over-the-air vehicle updates, and integrated satellite systems, including SATCOM, onboard drones, and the home. Customers can configure and arrange the vehicle to suit their needs, like a Rubik's Cube on wheels. We power up the space to deliver energy where it matters. Over this 100 kilometers range. And fulfilling customers' needs for city, intercity, and interstate mobility. Zero carbon ecology helps to power the car. A zero carbon life free from range anxiety. V2L functionality offers customers the convenience of charging all devices anywhere, anytime. Multiple drive configurations from a world standard electric powertrain will look after you along the journey. We protect space for the ultimate in safety and peace of mind mobility. Hundreds of battery pack tests and vehicle crash tests. NCAP 5-star safety ratings. Users' data privacy protected to GDPR standards. That's our commitment to road safety. This is SOA, LEVC, space-oriented architecture, built for all mobility scenarios.
So, David, now I welcome you up to stage. Talk about how smart you are.
Okay.
Yeah, take over.
Thanks, Kent, for giving me this smart pillar. Okay, hello everyone, I'm David. 正如 Kent 所介绍的 ，SOA 架构奠定了 X Space 超大空间、百变灵活、绿色零碳、极致安全的特性。而我今天所介绍的 LOS 将赋予 X Space 智能化、数字化与可进化的能力，它是 X Space 的灵魂。为用户打造定制化的豪华空间，一直是 LOS 的设计理念。SOA 超大空间的空间和我们的智能交互，需要与用户来进行智能交互，来最大限度的发挥价值。这需要我们从功能到硬件到软件以及到数据流的全脉络打通和管理。LOS 正是应对这样的需求而开发的智能化系统。可以说 ，LOS 是我们扩大化的、完整的智能操作化系统。它打通了我们的意义架构、我们的芯片层、我们的车辆操作系统层，以及我们的车控层以及生态，是一个完整的智能化系统。基于吉利的全球生态，使我们的 LOS 具备了开放性，而整个的规模化效应也保证了它的整体的稳定性。LOS 不仅能够为用户带来极致化的体验，而且还能够支持未来功能的持续迭代升级，它就是 X Space 的灵魂。接下来我来介绍一下我们的意义架构。LOS 的意义架构分为车身、动力、智能驾驶、智能座舱和网关5大域。整车的全部功能和所有的智能化体验，通过这些控制器得以控制和实现。那么，基于千兆以太网以及 FlexRay 的主干网络，使我们具备高带宽、低延迟的通讯效果，可以支持高级别自动驾驶对于通信带宽的需求。那么，同时这一套架构也为完全的自动驾驶具备了全冗余的备份。那么，在功能安全以及信息安全方面，我们也进行了全面的部署、全面合规。那么，未来我们的 LOS 新一代的意义架构将是一个以中央超级计算机搭配2个区域控制器为核心的中央超算平台，并通过以太环网将所有的控制器以及传感器配合起来，这样进一步的减少了 ECU 的数量，同时也保证了信息传输速度，并且提高了安全性，并且它是一个全面支持服务化的通讯架构。那么，在我们的车控系统层，为了实现整体功能的集成和对硬件能力的最大化发挥，我们构建了 LOS 一体化的软件解决方案，也就是 CarOS 操作系统层。作为整体数据空间的枢纽，它整体协调我们的整车车控、智能座舱以及智能驾驶。那么 CarOS 作为分层的软件架构，并具备着一码多端、具备强大的 OTA 迭代能力，并且支持功能的持续快速迭代升级，高度整合整车的控制器。那么，场景定义出行、空间成就场景 ，SOA 超大的空间需要智能座舱系统来提供智能化的赋能。 那么在视觉体验方面，我们需要高清的屏幕，需要3D 的视觉效果，那么也需要多屏的互动。空间大了之后，那么需要更多的屏幕来提供信息的显示，以及大的屏幕来给予更好的视觉效果。而在沉浸的音效体验方面，我们需要高品质的音场以及音效，以及海量的音乐资源。那么这些以上的场景和需求，都需要更大算力的座舱计算平台来提供算力的支撑。那么通过和吉利旗下我们的科技公司 ECARX 的通力合作、协同研发，打造了我们今天的整体的座舱系统。LOS 的座舱系统率先搭载安塔拉 Pro 1000的整个智舱控制器，它具备2颗7纳米的104芯片，是我们旗舰的智能化智舱计算平台，集成了这2颗芯片，相当于2颗高通的8155，具备高性能、低能耗的特点。那么与此同时，我们的内存配备了 LPDDR5这样的内存配置，使得我们整体的数据传输速度提升50%，数据传输带宽拓宽了50%，整体的功耗可以降低10%。那么这一套座舱系统，同时也实现了全链路的功能安全，获得了 SLB 的产品认证。LOS 的旗舰座舱系统可以支持最大8个屏幕显示不同的内容，12路的摄像头，并且支持3D 的导航以及3D 的 HMI 设计，4核的 HiFi 5整体的音效算力，支持高品质的音频处理。那么以上整体的高性能，会为强悍的这种能力，会为我们的用户带来越级的体验，为我们的用户探索数据空间带来更多的可能。那么 LOS 整体化全球部署的整体的生态系统，将为更多的用户带来它在当地所在的当地的市场，能够体验到我们 APP 所带来的便利和更加丰富的服务。来到自动驾驶，那么得益于 LOS 意义架构的整体的系统能力和我们多种智能驾驶方案的储备 ，LOS 的整体的自动驾驶实施的路径，我们有着清晰的规划和独立的思考。那么在第一个阶段，也就是在2023年到2025年这个区间，那么我们首先关注于空间导向型用户所最关注的要素，这就是安全。那么安全性能是我们整个 LOS 的智能驾驶系统在当前考虑的最重要的点。那么我们会根据不同的车型来匹配不同的智能驾驶的系统方案。当前会以安全辅助的功能为主，那么计划在2025年升级感知系统以及算力平台，那么将我们的 NOP 功能集成上去，达到 L2++ 的系统能力。那么在第二个阶段，极致的空间加上 L4级别的自动驾驶，那这样会给用户在整个空间使用上会带来极致的享受。我们会将时间还给用户，让机器来代替进行驾驶，那么充分的让用户来体验我们的空间。基于以上思考，我们在推进当前的 L4自动级别的驾驶的开发，为用户更多的用户来提供我们智能座舱、智能驾驶以及 LOS 整体的智能化的服务，一直是我们思考的目标。所以 SOA 与 LOS 的研发，它所基于的法规标准是非常高的，满足中英欧全面的高标准的法规要求，充分保证在目标市场的高标准交付，那么也同时能够达成通用化，缩短开发周期，针对不同的目标市场部署不同的产品。空间导向型架构加上我们的智能化的系统，需要突破原有非常多的技术边界，需要我们大家一起共同的 努力去打破这些技术边界，需要我们科技生态伙伴来共同的创新，共同的挑战极限。SOA 架构与 LOS 智能化系统，我们的伙伴一路走来，大家一起追求极致，无数次的突破自我，为了竞争力而携手并进。那么现在就让我们一起来听一听我的伙伴们的心声，以及他们为今天的 Tag Day 所带来的祝福。请看 VCR。
Hello everyone, my name is Frank. To support LEVC's space-oriented architecture, we from Bosch contribute our new integrated braking system, which is optimized for new energy vehicles. We also implemented new software functions, such as our distributed traction control system, we call it DTCS. The software is distributed across the vehicle, so it can react a lot faster to changing road conditions, such as ice and snow, and keep the vehicle as stable as possible under all conditions. We are proud to contribute to Geely's global R&D technology to make SOA one of the safest architectures possible.
大家好，我是王忠。基于 SOA 架构的极致空间理念和纯平地板设计，我们与 LEVC 共同研发的新一代座椅，可实现超长滑动、连续性无级调节，满足用户车内空间创变需求，成就空间自由。还有第4排座椅放平、钓鱼模式等功能，为用户打造一个人性化、个性化、娱乐化的舒适交互空间。SOA 架构是汽车行业的一次技术革新，为 SOA 架构在空间创变上赋能。
各位好，我是一卡通科技董事长 CEO 沈子宇。一卡通科技始终致力于打造强大的全站汽车计算平台，赋能全球品牌将下一代汽车转变为时刻在线互联的智能终端。LEVC 此次全球首发的 SOA 架构，将以其优越的空间特性及电子电器架构，为数字化座舱提供拓展空间。一卡通科技将基于先进的中央计算平台与智能座舱开发经验，与 LEVC 在全球开展合作，共同打造行业领先的智慧座舱产品。在这里祝福 LEVC SOA 架构发布成功，让我们携手在全球共同推进汽车智能化的持续发展。
那么 SOA 与 LOS 作为技术支持，作为整体的技术基石，全面支撑了 X-Space 的极致的空间设计理念。在此之上，我们可以拓展为 Sharing Space、Lesser Space、Business Space、Utility Space、Deliver Space。以上 X-Space 的5重奏，那么体现了我们 LEVC 对空间技术的突破，以及 SOA 架构超强的拓展能力，同时也为用户带来了极致的出行体验。Hello, X-Space. Future is here. Next, let's welcome our CEO, Alex, to give his speech. Welcome.
Hello, everyone. I'm Alex. I would like to say thank you all for attending today's event. 我想通过今天的发布会，大家都知道 ，LEVC 这家公司已经存续了115年了。115年以来 ，LEVC 深耕出行服务，持续进化，不断以技术创新为人们提供极致的出行空间体验。今天，智能电动化的技术革命，给予我们开创未来出行空间的无限想象力。刚才 我的同事克里斯先生给大家回顾了 LEVC 的发展史。大家可以看到 LEVC 的发展史呀，就是出行的进化史，也是技术服务场景的创新史。不管是大转角的小转弯半径，还是超大的乘坐空间，还是隐藏式的斜坡踏板，很多在空间应用上的技术创新都源自于 LEVC。 所以说 LEVC 它始终是轮上空间变革的推动者。肯特先生和戴维先生两位分别介绍了我们今天的最新技术成果。这是我们 LEVC 的硬件与软件的核心技术架构 SOA 和 LOS。 这个技术是我们依托吉利全球化技术体系的集成应用，是 LEVC 形成自主研发能力的技术底座。今天的 Tech Day 其实也标志着 LEVC 成为智能电动化新时代的掌握整车核心技术的新青年。今天的主题是 X Space， 那么这也意味着我们将会传承 LEVC 115年以来的出行经验，融合先进的智能电动化技术，开发新车型的一个研发方向。X 代表着未来， X 代表着多元。我们会坚持 LEVC 的品牌 DNA， 不断的去深化发展，发挥我们一直以来的空间主义，依托我们 SOA 和 LOS 的技术底座，秉承我们今天发布的 X Space 这么一个产品战略，去开发智能纯电动的新物种，为全球的用户提供至上的空间体验。我们有着悠久的历史，我们已拥有了非常先进的技术。我们今天发布的 SOA 和 LOS 这样一个新技术，对既有的技术，它是一种技术路线的加法。所以我们在技术路线的解决方案上，我们会不断的做加法。那么在为用户的价值创造上，我们会不断的做乘法。展望未来，我们将会携手上下游的合作伙伴，领导 LEVC 从英国走向全球，立志将 LEVC 塑造成全球领先的零碳出行科技公司。与此同时，我们也愿意以开放的心态，与同行交流共创，携手合作，加速出行迈向碳中和时代，为社会的持续发展创造价值。A sustainable future, a better world. Thank you.